going to discuss the fourth question of weekly contest 498. I've already made a separate video for the first three questions, so I'll link it out in the description. Feel free to check it out. Okay, so let's go through this question. It is a LeetCode hard question, and in this question we are given two integers L and R, which is this, and we need to find all the integers in the range L to R which satisfy some constraints, right? We need to do something. I'll explain what it actually means. So we are also given direction, right? So let me first take it and then take the example, and then we'll understand what the actual operations here they have mentioned, right? Okay, so I think I can take this one. Let me copy it, right? Just take this and let's try to understand the problem statement. Okay. Okay, so yeah, we have it, right? So what it is saying, all the numbers in the range L to R, it should be represented in a 16 digit format, right? So let's say if our number is let's say it's 17, right? So 17, it's 2 digit, right? So the first 15 digit, it will be 0 0 0 0. So initial 15 digit, it will be 0 15 and 1 and 7. Okay, and then we need to represent it in a matrix. Okay, in a 4x4 matrix. So it will be something like this, 4x4, right? And they are said it's represented in row measure fashion, right? So I am just showing it for 17. So what it will be, so this will be row measure, right? So it will say row measure. Okay, so 0 0. So 17 last two will be this, and all this will be 0, right? So this is the first thing. Now can we say if 17 is good or not? So how do we decide if 17 is good or not? So they are given this string D, right? Direction. So which is like this. So DDRR. So what we'll do is, if it's D, that means move down. So move down. If we are currently at here, so we'll move 1 unit down. And if it is R, we'll move. If we are here, we'll move 1 unit this. So here it will be x and y. It will become x plus 1 comma y. And here if it is x comma y, then it will become x and sorry, it will be x plus 1 comma y, and this will be x comma y plus 1. Okay, sorry. So I hope this is clear, right? So this is what movement means. So it is saying, like, initially if we are here, right? Okay, so it is saying the first character, what is it? It's D. So we'll move down. So this is our path. What is the next character? It's again D. So we'll move down. What is the next character? It's R. So we'll move one step on this. Okay, now what is the next character? This is also R. So we'll move this. And what is the next character? It is D. We'll move this. And what is the next character? R. So is it non-decreasing? This path, like 0 0 0 0 0 0 0 0. So 5 0 and 1 7. Is it non-decreasing? Non-decreasing. This one? Yep, it is a non-decreasing, right? It's not decreasing. Okay, so 17 will be 17 for 17, answer will be 1. So we need to find all the integers. So this was just for 17, right? So we need to find all the integers in the range L to R. So if, let's say, if L is 8 and R is 10, so we need to check if 8 is 8 when we make this grid representation, will it be a non-decreasing one for 9 and for 10, right? We need to check all the numbers in the range. Now, so I hope the question is clear, and what needs to be done is clear. Now, the major issue is, right, I can represent it very easily in this format, every number in the range L to R in this format. But if I try to go for every number one by one, so I try for 8, I try for 9, if I try for 10, it will lead to time complexity, a great time complexity, right? Because the constraint that we are given in this question, right, if you see, it's 10 to the power 15, right? And direction length is 6. So we'll start from here, then we'll reach up to here. Okay, so we can't compute it one by one for all. It will lead to TLE, right? Because of n into 16, that will be too big. N is L minus R, R minus L plus 1. That will be too big, right? It will lead to TLE. So what can be the other way that we can take? And usually whenever like questions like this come where you see the range, we can't do one by one. One by one is not allowed. It is giving to TLE. Okay, in that cases we know it's a question of digit DP use. So that's the usual intuition or hint why I am gonna think of digit DP, right? So what actually digit DP says is, like, instead of checking it for every number, like let's say for L to L plus 1, L plus 2, instead of checking for all the numbers up to this, we try to form the number such that it satisfies the constraint. Like, let's say if this is currently we are trying to form, let's say if the we try to place digits here, what numbers can be placed? It can be like 0, 1, 2, something like up to 9. Similarly, this here also we try to put 1, 2, 3 up to like 9, right? Such that we only put all those digits that satisfy the constraint, such that they don't exceed or the constraint is satisfied. So that's the usual intuition for digit DP usually. And in this case, if you can see, right, while I was forming the path, right, you can say at most the path will be of 7 length, right? Because the direction is given to be 6. Direction is 6, and at most it will be the path will be 7 length, right? So what I can think is, so I'll say one thumb rule that we usually have in digit DP is, like, let's say you need to calculate for L equals to something like, let's say 100, and R is 180, let's say, right? So if I start from here, let's say this is 100 and this is 180. Okay, so in usually what we do is digit DP, usual question, we calculate the value up to this, right? This is answer 1, and then we calculate the value up to this this is L minus 1, right? This will be L minus 1, and this will be answer 2, right? And what we do is we subtract answer 1 minus answer 2, which will give us this particular answer, right, from here. So that's how the usual intuition is when you try to solve a digit DP. So keep in mind this one. This is something we use standard approach, right? This is one of the standard that we use. Now in this particular question, how do we think of it? Like, let's take this example and then we'll try to understand how it is going through. Okay, so let's see if this one, right? So let's say I'm trying to form the number. Okay, I'm trying to form the number, and I know only 7. So out of this 16, I don't care for all the places what number I'm putting, right? Let's say if I put let's here, we know this was the path, this. Let's say if whatever is the path, let's see, DDRR. Okay, DDRR. So this DDRR D and R. Okay, so this is the path actually in this one. So it doesn't matter if we put something like here 7, then also it doesn't matter, because all these places will not be covered in our path. So we are only concerned about the path that is we are following. Okay, so out of this 16, only 7 matters, only 7 places matter. So what I'm gonna say is, I'll store it something like this: what all index matter to me. Okay, so how is it actually done? So let's say this is 0, 1, 2, 3. I'll store if this index, while I'm forming the solution, is this index important to us? So this index is important, this is important, this is important. So what it actually, this is 0, 1, 2, 3, 4, 5, 6, 7. We can represent the 2D in a 1D format: 8, 9, 10, 11, 12, 13, 14, 15. So how do we get, for if it is at R, I and J, so the answer will be 4 into I plus J. And how do I reach to this? Let's say if we take this index, so it will be 2 comma 0, right? So it will be 4 into 2, 2 into 4 plus 0, which is equals to 8. So if you see 0, 1, 2, 3, 4, 5, 6, 7 and 8. So this is how we'll calculate. So we'll pre-compute out of this, if this is 16 places, path, which all is in our path. So if path of I is 1, that means it we care about this, else we don't care about this. Okay, so we'll first calculate this part. uh, Okay, and I'll just explain this is the thing that we are doing, right? So we'll have a path vector that is of length 16, and we run through it, and then we'll say if it is D, then row plus plus, else column plus plus, and this index path of this index is 1. So this is the thing that we have done so far. Okay, now let's go back to this. Now how do we actually solve it, right? So if you see, right, uh, I'm trying to form a 16-digit character, right? And what I can do is, like, let's say if this is the place, this. Okay, so let's say I put something like here I am there, right? Okay, let's say, let's take some small example, right? So 5 535 532. Okay, so this is our name. So at this places, what all numbers can I put? I can put 0 1 2 3 4 and 5. Okay, so if I put anything from 0 to 4, right here, I can put anything from 0 to 9, because the number is already smaller than 530 532. Because if I put 4 here, then anything that I put, it will be smaller, because 400. But the only thing is, if I put 5 here, the only if I put 5 here, if I put 0 to 4, then I can put here 0 to 9. But if I put 5 here, then in this case I can only put 0 1 2 or up to 3, right? So this is what we do in rigidDB. So we keep a variable is smaller, so which says, like, if the number that we are trying to construct, has it already been made smaller? So that is something people also refer to as tight. And while I use this is smaller, so that helps me to understand. So if is smaller is equals to 1, that means the number is already smaller, and I have the options to take up from 0 to 9. If it is not smaller, then I can take maximum up to limit, like whatever is the value at this index, right? So this is what the ZDB actually concept is, and the main part of this particular solution is, so I whatever I'll need. Okay, so I try to form the solution iteratively. So what all values can I take at this position, right? And I will also see is this path. So we already have this path, right, which says like which all path matter to us. So let's say this path doesn't fall in the answer, right? Like, let's say this path doesn't fall in the answer, right? So I can put any number here and it doesn't matter to us. Okay, so I need to check, like, since I need to check is it decreasing or not, right? So is for number to check if it is decreasing or not, we need what is the previous value that we have put, right? Previous. So what is the previous character that we have taken in the path? So let's say here we have taken 2. So the next number that I'm going to put, it should be greater than 2, right? Greater than equals to 2. So I need a variable previous uh, in the standard template of digit DP that we have. So what I'm going to do is I will have one solve function, and I will have one index at what index I am. So I construct it digit by digit. Okay, what index I am, and I will also have a previous. So what is the previous digit that I have taken, and then I will also have this current string, right? String s that I am trying to form, like, which I'm comparing. So here it's 500 something that I have taken, right? This 532, this is s for us. I need to count all the number which is smaller than 532, and it is non-decreasing, right? So one will be s, right? And then, as I mentioned, I will also take is smaller, so which states like if the number is already smaller, and string s, right? So what I'm going to do is in my digit DP, so if this index is already reached 16, that means I have formed all the characters, because at max the grid size is 16, right? This is 16, so at max I can form 16, so I'll return 1 that I have formed this answer, right? The other case will be, I'll find the limit, like what is the elements that I can digit that I can take at this character. So if limit, so it is equals to, let's say, 9, right? If is smaller is false, that is if the number is not smaller, that it means we have taken 5 here. In that case we can already take, like, if is smaller is not true, is equals to 0, in that case limit will be whatever is the value, like at this index, what is the value? Like here, say it's 3, right? So s of index minus 0, so that convert into this. Okay, and now I will try to do loop, and I will try to place digit here one by one, right? So digit is 0 and digit up to limit and digit plus plus. Like I hope you know, like for this particular problem, digit dp is a requirement. So do read digit dp before you jump onto this video, or after you if you are stuck, read some digit dp solution so that you know much on this. Okay, I will just check if this value, right? So if I have already have a previous, so if this value, if the current value that I am taking, if the digit is smaller than my previous value, then I can't do anything, right? I need to continue. No, 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 no. First I will check, is this digit important? Like, okay, is it a part of our path, right? So I'll see this one, right? I'll see like, okay, if I'm on this red path, so I need to check if it is following the thing, right? It needs to be greater than this digit needs to be greater than at least or equals to this. But if I'm here somewhere like here or here, I don't care. I can put anything like 0, 1, 2, 3, 9, just that it follows the constraint, like it's less than 532. Okay. So what I'm going to do is, if this particular digit index, if it is on the path, if is part of index, if it falls on this path, right, index is equals to 0. If it doesn't falls in this path, no, it falls. If it's part of index, that means it falls on this path, right? So I'll first initialize the answer is 0, right? That means it falls on this path. So I need to check if it is greater than equals to previous character, right? So if at this index, right, if let's say I'm coming up here and it matters to me, so I have taken this one, like let's say here I've taken 1, right, and here I took anything because it didn't matter, so 1 I put 6, right, let's say, doesn't matter to me. So I need to check at this index, whatever I put, it is greater than equals to 1. Okay, so if this digit value, it is smaller than the previous, so I can't put 1 less than 1 here, right? If this value is smaller than previous, in that case I'm going to continue, else I'll put in our answer and I'll call it recursively. Okay, so index will increase by 1, that is I'll go to this digit, and my previous, it will be the current digit that I have taken, and is smaller, so is smaller will be, how do I check if it's smaller? So usually that we have, right, is smaller, the new is smaller, right? In digit dp we usually take smaller, that it says like, is the number already smaller or not? So okay, so that stores. I can explain this part if you need, else we'll move on. Else it doesn't matter to it doesn't matter to us, like it is this index, so it doesn't matter any value we can put, just that it is just smaller than 532, the number that we are trying to form. Okay, it doesn't matter, we don't need to check if it is greater than equals to 1 or not. It can have been 0 also as well, because it will not form in our path, like this index is not a path form of our path, right? Let's say it falls somewhere like here or here, right? It is not a form part of our path that we're trying to follow. In that case, answer plus equals to, we'll do solve and we'll put index plus 1, and this will be previous, the previous will remain the same, is smaller this and this s, and at the end we'll return the answer. Now if you want to see how this is smaller, if the current number is already smaller or not, in that case you can form take this. So new is smaller, we can have is smaller, so it will say if is smaller is equals to uh, we'll say is smaller. So if it is already smaller, right, if the number is already if new smaller is already smaller, that means like the digit that we're trying to form is already smaller, we know it's already smaller, like something that we have put, like let's say we're trying to form 543, all the number less than 543, and we have put 4, right? That means the number has already been smaller. Else case will be, let's say if it is not already smaller, but here we put something like 2, then it becomes is smaller, right? So it will be is smaller or this. I can better explain it in the code part itself. That will be much easier for you guys to understand, right? So this will be this, and right, is the digit that we are trying to put, is it less than limit, right? If it is less than limit, then the answer it will be new smaller, and here it will be putting new smaller. Similarly, new smaller. Now the one more thing is like okay, so I think this pretty much it for this DP part, and we can memorize it because the only parameter that is changing is index, this previous digit, and is smaller, right? And is smaller will be boolean, that is either is smaller is it smaller, it is always 0 or 1. Previous it will be like from 0 to 9, right? And index will be like max 16, 0 to 16, right? Since it's 16, so it will be 0 to 15, but for worst case we'll take like 0 to 15. So the DP that we're gonna form is, I'm putting this. So usually the one trick that I actually use for DP is like I'll put, if I need to form a 3D DP, right? Like this, I can take any number like this. I will take usually 17 size. This will be 10 size, so I'll put one extra. This will be 0 and 1, so I will put, I know, 2 size, right? So I usually put like the number in decreasing format because it will take a much smaller space. I guess it takes similar, but something that I've read, and I usually prefer the smaller one to be taken first. So I'll take 2 here, then I will take 11 here, and then I will take 17. So this will be my DP, and DP of is smaller. Here I can put if DP of is smaller, and then I can put previous, and then I can put index. If it is not equals to -1, then return it, then return the same, this DP of this. Else at the last I will before storing, I'll returning the answer, I will store it and return, right? And that's pretty much it for this one. But the main thing was the digit DP part. I hope you already know digit DP, and the only important thing in this was like, is it falling on our path? Is the index that we are taking, is it falling in our path like this? If it doesn't fall in our path, then we don't need to consider it, else we'll unconsider it. So that's pretty much it for this one. I know it was a bit tough one, but if you know digit DP, it makes more sense. So let's say, so the very first thing is this one that I have formed, like, is it following in our path? Like this is the thing that I have formed, like this one, and whatever path we have like this, so in this case it will store this path. Now we as mentioned in digit DP, we form this left and right, so we'll store this right, and this we have left. So answer one will be this one right, whatever is the value up to right, and answer two will be value up to left -1. So here left is left L -1. So this is the answer 2, and this is the answer 1, and final answer will be answer 1 minus answer 2, right? Now let's move to this. And while it's mentioned, right, if R is this, then what I usually do is I will make it to 16 characters, 16 digits, and on the left, however is remaining, I'll put 0. So if this is how much character, this is 10 characters, so the top 6 character will be 0. So that is what I have done here and here. So both L and I will make it 16 digit. Now next part is the is part that I've already explained, right? And this is the solve function, right, that we are talking about. So it has an index. Is it already smaller, and what is the previous character that we have taken? So if index is 16, we'll return 1, and this is the memorization part. So in answer we have this. So, and now we go to the limit. So what is the new limit that we have? So if it is already smaller, then we'll take 9. S will take S of index minus 0, like as I'm explained here. If it is already smaller, then we'll take this, else we'll take 9, right? This. Now I try to place at this current index, I will try to put all the digits from 0 to limit one by one. So our new smaller will be, if it is already smaller, then it is 1. Else if the digit is less than smaller, like let's say it was 532 I was trying to place, and till now is smaller, is 0, right? So here I have put 5. Now if I put 2, because our limit is up to 3, right? I can put here 0, 1, 2, and 3. If I put anything less than 3, my is smaller is 1, because next whatever I put, it will be always less than 532, right? So that is what it says. But if I put 3 here, so it won't be smaller, so it will be 0. It will still remain the same, whatever it was is smaller. So that is what it says, right? This one, sorry. right? Now I'll say, is this current index a path of, is this current index in our path that we are trying to form with this direction? If yes, then I will check if the digit is less than previous, right? So while I was trying to explain this part, I hope I explained this, and you are able to understand as well, right? So if this index falls in our path and our previous character that we have taken is 1, so at this index it should be greater than or equals to 1. Okay, if it is, let's say if it is here it's 0, so it will be 1 and then 0. It's non-decreasing, is the non-decreasing character is false, right? So that is what I have explained here. So the digit that we are taking currently, it should be greater than or equals to at least previous. If it is not, then we'll return, then it will continue. Else we'll uh, edit in our answer and call the recursive function solve next index, new smaller is this whatever we have done, and the current digit that we have taken here is the previous digit. So whatever we take is the current digit here. Else it doesn't, this digit doesn't fall in our path, so it doesn't matter, it can be anything. So we don't need to take in our don't need to update our previous, so the previous will still remain 1, so it doesn't matter to us. So it will be solve index plus 1 new smaller, and the previous will still remain the same. At the end we are storing the answer before returning in the DP. So that's pretty much it for this one. I hope you're able to explain. The main thing in this one was this is path, which was saying whether we need to take it in our path or not, and after that it was just this previous, yes, small, the standard DP, and we just needed the previous part. Okay, so I hope this was understandable. If you have any doubts, do feel free to reach out to me in the comment section. I will help you in explaining. And yeah, do read about Digit DP. We'll meet in the next weekly contest. Thank you.